Hello everybody, now I would like to go over some examples about expected value and variance, and here are, I believe, 4 examples. And here we go with the first example. Oops, let me change my board marker here. Let's make it blue this time. So number 1, you and a friend play a game where you each toss a balanced coin. All right, a balanced coin. It means it's also referred to as a fair coin. What it means is when we say a coin is fair, the probability of heads is equal to probability of tails, and both of these are equal to 1/2. All right, so probability of heads is 1/2, probability of tails is 1/2. If the upper faces on the coins are both tails, you win $1. So if they come tail when you each toss this coin, if both of you toss the same tail each, then you win $1, and I assume your opponent is losing $1. If the faces are both heads, you flip a coin, you get a head. Your opponent flips a coin, your friend flips a coin, he gets a head as well. It's even better for you. You get $2 then. So as long as the coins match in terms of either tail or head, you win. If it's tail, you win $1. If it's both heads, you win $2. Actually, you know what? We can even write it as a random variable. Why not? Actually, hold on. I think it will end up being y, right? So that's, well, okay, let's finish reading the question and then let's write the notation. If the coins do not match, you lose $1. Ah, got it. So we lose $1. Give the probability distribution of your winnings. All right, so y is equal to, so the distribution will be the following. So either you will win $2 if head with probability, well, what's the probability that you flip 2 coins, one you and your friend, both come up heads, that's 1/4. Or $1 if tail, we still win some money, right? With probability, well, both of them coming up tails is also 1/4. Or we will end up losing $1 if head tail or tail head. And the probability of such an outcome happening is 1/2, right? So 1/4 chance for head tail, 1/4 chance for tail head, so 1/2. Now the question is the probability distribution. We have it here. I mean, you can put it in a histogram, but that would be so you guys can have a look at that. What would be interesting, better than that, would be given our random variable y, which is our winnings in a single play of the game, what is the expected winnings? That's what I want to hear. What is the expected winnings? Again, y represent, maybe I should write that down. Your winnings, not your friend, you, your winnings on a single play of the game, let's say, play of the game. In a single play, you both flip just a single coin each. All right, so what is your expected winnings from this? Well, with probability 1/4, we'll earn $2. With probability 1/4, we'll earn $1, both positive. With probability 1/2, we will lose $1. Now we can add up these numbers. So $2 over 4, so that will be just 50 cents. 0.5 plus $1, 1/4 of it is 25 cents. And finally, the last one, minus 0.5, minus $0.5. Actually, let's just get rid of that dollar sign. I mean, that plus sign, minus 0.50. Hey, look at that. So your expected winnings from this game, let's say, is greater than $0. So in fact, you should pay some money to play this game. In fact, so what we can even say is for each play of this game, you can pay up to 25 cents if you are risk neutral. So if you have some risk neutral preferences, you should be willing to pay up to 25 cents to play this game, because that's the expected payoff from that game, right? Yeah, so that's pretty neat. And obviously you guys can also easily calculate the variance as well. Why not? So let me quickly calculate that as well. So the variance is just, okay, let's do the other formula, this one, ey squared minus e of y squared. So e of y came out as 25 cents. So all we need is e of y squared. So e of y squared is pretty much the same idea. 1/4, 2 squared is a 4. I will just drop the dollar signs. 1/4, 1 squared is a 1, plus 1/2 minus 1 squared is a 1. So that will come out, sorry. And then we still have, so that's the first part. And we still have ey squared. Ey was 0.25. And we need to square it. All right, so we have 1 plus 1/4 plus 1/2 minus, well, 0.25 squared. Why don't I write 0.25 as 1/4, right? So 1/4 squared, that's better. So this will come out as 1/16 as a result. Now remember, variance is a number which is always positive, right? Expected value sometimes can be negative. Not in this game, because apparently it turned out that this play is a good play for you. It favors you, and it definitely is a game where you can make 25 cents in average on every single game. Anyhow, so here the common denominator is 16, so we have 16 plus 4 plus 8 minus 1, all divided by 16. And finally, the variance of that random variable y comes out as 20, 28, 27/16. If you want, the standard deviation would be just the square root of that. I'll just leave that to you to finish. All right, so the second problem, here you go, question number 2. So we have an insurance company which issues a 1-year $1,000 policy insuring against an occurrence A that historically happens 2 out of 100 owners of that policy. So the probability of that occurrence A happening is 2%, I should say. And whenever it happens, it costs the insurance company $1,000. So there's a 98% chance nothing will happen. So the probability of A happening is 2%, or you can write it in decimal 0.02. And the probability of A not happening, not A, is 98%. Why 98%? It's 1 minus the probability of A happening, the probability of A. But the probability of A was 2%. So not A as a result is 0.98 or 98%. So with 2% chance, it will cost the insurance company an additional $1,000 above and beyond the administrative fees of $15. And with 98% chance, it will not cost anything other than just the administrative fees of managing this policy. Now the question says, how much should the company charge for the policy if it requires that the expected profit be $50 per policy? So the company, the insurance company, is expecting, he wants to make in average $50 for each policies that it sells. So why don't we just make that $50 profit equal to the expected earnings? So if there's a hint here, so if C is the premium that the company charges, obviously if A does not occur, this will be the profit, C minus 15. Why? Because there's a $15 administrative fee that's like a cost. C minus 15, revenue minus cost, will give you the profit. Or if A happens, that's the value of the profit. So therefore, the expected profit, by the way, so is equal to what? Is equal to, with 2% chance, nothing bad, the bad occurrence will happen, the event A will happen, and that will cost the insurance company an additional $1,000, or with 98% chance, no additional cost. Well, we want to make sure this number in the end equals $50, because that's the objective of the firm. It wants to generate $50 cash from selling these policies. Now the rest is very straightforward. One thing that can be done is, from the beginning, we can multiply both sides by 100 and then make it accordingly, or we can directly just distribute. I think I'm just going to go ahead and distribute this across and then this one as well. So here we have 0.02C, 0.98C, so you add them up, you get a C. And then we have minus 1015 times 0.02, so minus 0.02 times 1015. Actually, let's put it in brackets here, plus there's also 0.98 minus 15 as well, so let's just write that as well, minus 0.98 times minus 15, so that ends up being a positive number in the end. Anyhow, so this implies, so we still have 50 on the left hand side. On the right hand side we have, well, you know what, we can move everything to the left hand side, right? So therefore on one side of the equation we will be left with the amount that the insurance company should charge, the premium, and that's equal to what? That's going to be equal to 50 plus, after we move this to the left hand side, 0.02 times 1015. Let me see if I have a calculator in front of me. Yes, I do have one. Let me just go ahead and open that. Okay, 1015 times 0.02, that's $20.30, and then minus 0.98 times 15. Let's do that. 15 times 0.98, 14.7, and finally that number is equal to, so let's just do it. It comes out $55.60 for the premium that the insurance company should charge to the company so that it can make a $50 profit from each policy sold. Yeah, I think I did a typo in here, didn't I? Because there was a plus sign here and somehow I put a minus there. So yeah, this was supposed to be a plus, sorry for that, which would make this one a plus. So therefore this number is not accurate actually. So this number was supposed to be, so we have, 20.30 plus 14.70, so that will give us 35, plus 50, that would give us $85. Actually, it's an even number. That's perfect. Let's move on to the third question. So we have two construction contracts are to be randomly assigned to one or more of three firms. So three firms are going to that bid for those two projects, right? So many different combinations can happen. Either both bids go to, if you check all the event space, let's write the event space, and we can calculate each of these events happening. So what can happen is both contracts go to the first firm, or both contracts go to the second firm, 2. Both contracts go to the third firm, contract 1, contract 2. Or it might as well be that contract 1 goes to the first firm, contract 2 goes to the second firm, or contract 1 goes to the first firm, contract 2 goes to the third firm. That's yeah, that's pretty much all the combinations for the first firm getting the contract. Or the first contract goes to the second firm, the second contract goes to the first firm, or the first contract goes to the second firm, the second contract goes to the third firm. Oh boy. First contract goes to the first firm, third firm, the second contract goes to the first firm, and finally third contract goes to the first firm, and then second contract goes to the second firm. That's pretty much it. Each of these events are equally likely, and when you look at it, you can also see how many contracts each firm gets. So let's define it xi, or x1, x2, x3. Let's do it one by one. X1 is the number of contracts earned or received by firm 1, and similarly for x2, number of contracts that the second company received, number of contracts firm 2, and x3 is the number of contracts firm, let's write it in Roman numerals, right? So firm 2 like we did above, and firm 3 here. All right, so you guys can easily derive the probability distribution, I guess. So x1 is either 0, either it gets no contracts, or a single contract, or 2 contracts. So we can see X1 will get no contract here, 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 and here. So all the other occasions we will get some sort of contract. So 1, 2, 3, 4. So with probability 4/9. With probability 4/9, the first company is not gonna get any contract. Actually, let's also write these Roman numerals, right? There you go. The same thing for this one, X2, and this is the random variable associated with the number of contracts the third firm gets. How about one contracts? Among all these, how many of them, well, this one is a 2 contract, not that one. So that's 1, 2, 3, 4 of them with probability 4/9, 4/9. And finally, 2 contracts is only this one, right? With probability 1/9. Does that make sense? And guess what? Pretty much this is also the same for the random variable associated with the number of contracts received by firm 2 and the number of contracts received by firm 3. Now we can say that if each contract yields a $90,000 profit for the firm that gets that contract, we can find the expected profit for the first firm, for instance. In average, how much profit will the first firm make? Which will be basically the same for firm 2 and firm 3 because they are symmetric. So the expected earnings, well, expected, I should say, profit for firm 1 is just, well, it's just the product, expectation of the product of $90 times number of contracts, which is X1. So I'm doing this for the first firm, so profit of firm 1. All right, so that's just, hey, 90,000 is just a constant, so I can just factor it out. Expected value of Xi, hey, that's easy, right? So $90,000 times, okay, let's calculate the expected value of X1. So 0 with probability 4/9, 1 with probability 4/9, and 2 with probability 1/9. Long behold, that adds up to, so this one drops, 4/9 plus 2/9, that's 6/9. So 90,000 times 6/9, that will make $60,000. So this is the expected earnings, the expected profit that this company, the first company, will make. And it turns out that that profit is the same for expected profit for company 2 and expected profit for company 3 is also the same. Well, the second part of the question says, what if firms 1 and 2 are actually owned by the same individual? What is the owner's expected total profit? Well, expected total profit from the first firm was $60,000. The second firm, the profit is also $60,000, so the sum would be $120,000. So that was question number, wait, was this 2 or 3? Okay, that was question 3. Perfect. And last question, question number 4. A potential customer for an $85,000 fire insurance policy possesses a home in an area that, according to experience, may sustain a total loss in a given year with probability 0.001 and a 50% loss with probability 0.01, ignoring all other partial losses. So basically there are 3. So if X represents the random variable associated with losses, so dollar losses, I mean dollar losses. So X can be, well, the loss can be as high as, I think, everything, right? $85,000 loss with very unlikely, right? The probability of this happening is very, very unlikely, or this is just 0.1%, very, very low percentage. Or we will lose half of the property, so it will cost the insurance company this much, half of $85,000. This one will happen with a slightly higher probability, 0.01 chance, which is basically 1% chance. And pretty much everything else, there's no loss for the company. So this is like what? A tiny bit less than 99%, right? So 98.9% chance the loss for the insurance company will be 0. So like we said, so what should be the premium that the insurance company should charge to just break even. That's it. It's not even trying to put a profit margin. In the previous question, I think it was in question number 2, the company was trying to put a $50 margin for each sale, right? This one we don't even try to do that. So it's just a straightforward calculation of just trying to break even, basically. So therefore, we are trying to make the expected losses equal to 0, right? That's our goal. So what should be charged so that that expectation, this should be equal to the amount we charge, sorry. So therefore, does that make sense? Because, okay, so let me explain what I mean. So if this is the expected losses, because X represent losses, right? So E of X is expected losses, the average losses. This better equals to the amount charged, and that will imply that the amount charged minus the expected losses is equal to 0 if you just move the expected losses to the same side with the amount charged, right? So that's it. So that's our goal. Like we said, so let's just go ahead and calculate expected losses, and that's it. So expected losses is basically the amount that we will go ahead and charge, basically. All right, so expected losses, like we said, with a 0.1%. Let's write it in decimal. I think this one is better. All right, so which is actually fraction is better. So this one is, okay, let's just do it. I don't want to lose more time. Times an $85,000 loss with 0.01 probability. The loss would be 42,500, and finally with a 0.989 probability, the loss would be 0. So we can just multiply these and add them up. So we have 85 plus this one is going to be 425 plus the last one is just a 0. And adding these two, I think it comes out as $510. That's it. So the insurance company should charge at $510 so as to break even, right? So that was the goal, just to break even, and we can break even as such. Hope this was useful, and in the next video, we will continue.